This video is going to be about a certain physical property of matter called density. The density of a material is defined as its mass per unit volume. Algebraically, that means that d density is equal to mass divided by its volume. So therefore, the units for density are typically grams per cubic centimeter or grams per milliliter, since grams are the units that we tend to use for finding mass. Cubic centimeters or milliliters, the units that we use for solving for volume. So if I want to find the density of an object, I would simply find the object's mass and divide it by the object's volume. Now, finding the object's mass is easy. You just use a balance. Put it on the balance, read whatever the balance says. That's the mass of the object. Volume, we've all learned, is always length times width times height. So you would use a ruler, obviously use centimeters because we use the metric system. Measure the length, measure the width, measure the height, multiply them, that would be in cubic centimeters. But not everything is cubic in shape. So if you have something that's irregular in shape, you have to do something called water displacement. You take a graduated cylinder, fill it to a certain amount with water, add your irregularly shaped object. What happens? The water goes up in volume. This change in volume right here represents the volume of the object that you're trying to measure. And these two volumes right here you can use, you can actually measure with the graduated cylinder, subtract them, that's going to get you the volume of the object. Now, one thing you can do with density is compare them to other objects that have density. Normally, if you put something into another piece of matter, if it sinks down to the bottom, that means that that piece of matter that sank down to the bottom is more dense than the object that you put it into. So for example, this ping pong ball on top clearly is less dense than this bolt down here. And we have all these different objects. We've got maple syrup, milk, we've got water right here. It's colored so that you can see it. Vegetable oil. This is dish soap right here. A tomato is right here. Now, water, which is kind of convenient, has a density of 1. So what that means, what that tells us, is everything above, floating on top of water, has a density less than 1. Everything below water has a density more than 1. So this aluminum bolt right here has a density of 2.7, greater than 1, therefore it sinks. Now, let's take these 5 boxes and play with them and see what we can figure out. If I take box B and drop it in the water, it floats. So what does that tell me? Box B has a density less than 1. Box A sinks in water, matter of fact, sink pretty fast. So I would assume that box A has a density greater than 1, matter of fact, quite a bit greater than 1. How about E? E's pretty small, so it should probably float, right? No, because it is small in shape, its volume is small, but obviously it has a very, very large mass, therefore its density is greater than 1. D just barely floats, so it's less than 1, but not by a lot, so maybe like a 0.9, 0.95. C floats pretty well above water, so, you know, if I had to guesstimate, 0.7, 0.8. Now I could find this out. I could find the mass of block C, and if you'll notice, when I take this out, look what happens to my volume over here. It goes from 108.12 up to 112.20. If I subtract that, that would represent the volume of box C. Take the mass of box C, divide it by the volume of box C, and I would get the density. Okay. Another cool thing you can do is if you take a regular can of Coke and a Diet Coke and put them in water, you get different results. First of all, notice that the Diet Coke is floating and the regular Coke sank. Now, the first thing I can probably predict from this is this. Diet Coke has a density less than 1 because it's floating in water. Regular Coke has a density greater than 1 because it sinks in water. Okay, why? Well, first of all, these two sodas have the same volume. They have the same amount of soda inside of them. So what's different? Well, Diet Pepsi has less what? Less sugar. Therefore, it weighs less. Pepsi has sugar. It has a lot of sugar. Therefore, it has a larger mass. So here's the Diet Coke, okay? And over here, this is the regular Coke. It has the same volume, but a larger mass. Therefore, what happens to the density? It goes up. It's bigger, and therefore it sinks. Water, there's something special about water. Water has a specific property that when water freezes, when it turns into a solid, it expands. Not too many things do that. Okay? So notice that ice is floating on top of water. Number one, that tells me that ice has a density less than 1, like 0.95. Okay? Now, why is that? Well, it's all made of water. How is that possible? So here's the density of water. It's mass divided by volume. And if I take water and I freeze it, it's still going to have the same mass. So my mass is the same. But because it expands, that volume gets larger. And since I'm dividing by a larger value, my density gets smaller. And therefore it floats. Now notice this. It doesn't matter what the size of the piece of ice is. A little ice cube floats. A massive, massive chunk of ice still floats. That's called an extensive physical property. It does not depend on amount. If I have a small piece of ice, large piece of ice, they both still have the same density.